All right, guys, welcome to the last lesson of Unit 2. Okay, so as you see on the slide right now, right, we have a house, similar to what we did yesterday or the day before, depending on when you saw me, okay? And we talked about how when I am talking about an electron, I can be super duper specific about where you live in a house, right? The reason I have a drawing of a house today is because we're going to be talking about orbital diagrams, and that's very similar to what we did with electron configuration. But instead of just telling you the directions, right, I can draw it out. All right. So our objectives today are that you can determine the orbital notation for an atom using the Aufbau principle, Hund's rule, and Pauli exclusion principle. And I can determine the number of valence electrons from electron configurations, all right? So, orbital diagrams are just pictorial descriptions of electrons in an atom, right? So the other day we wrote them out, okay? Today we're going to be drawing them out, right? But in order to write an orbital diagram, you guys need to know the rules, and I have 3 rules. My first rule is that we have the Aufbau principle, and that says that electrons fill in the lowest available energy levels until they are full and then move to the next energy level, right? So super similar to the Bohr model, right? We saw that we filled in that first energy level with our electrons, then we moved to the second, we filled in the second, then we filled in the third, right? So same thing with the Aufbau principle. I have to fill in each individual orbital before moving to the next, okay? So the lower the principal quantum number, so my n value, right, my 1, 2, 3, 4, the lower energy I have. And within an energy level, I have s orbitals that are the lowest, then p, then d, then f. Okay, so I'm going to fill in a 1s completely before I move to a 2s. Then fill in the 2p before moving to my 3s, okay? My Pauli exclusion principle says that each orbital holds a maximum of 2 electrons, okay, each with opposite spins, okay? So we usually represent that with an up and a down arrow showing that they're an opposite spin, okay? Since there's only one s orbital, okay, 2 electrons will fill that, okay? For p, there are 3 different orbitals, each holding a total of 2, so 6 total electrons. We saw that with P. 5, or for D, I'm going to have 5 of these squares. For F, I'm going to have 7, okay, to max out my total electrons. Hund's rule is my last rule. It says that, sorry guys, I'm super sleepy. Okay. Hund's rules say that electrons fill equal energy orbitals so that a maximum number of unpaired electrons result. Meaning, electrons fill up each orbital once before doubling up, right? So you see this here, right? For this atom, right, I have a completely filled 1s, I have a completely filled 2s, and in 2p I have 2 electrons, right? So I'm going to fill in each one of these one time before doubling up. So this is the correct orientation. I'm not going to do an up and down first row. This is wrong. Okay. To draw orbital diagrams, I have 3 steps. Okay, my first step is to write out my full electron configuration. Okay, we did that the other day, so more practice on that today. Then I'm going to draw out a skeleton. Okay, so for every time you see an S, you're going to draw a square. For every time you see a P, you're going to draw 3 squares. Anytime you see D, you're going to draw out 5. And then anytime you see F, you're going to draw out 7. And then I'm going to fill in my number of electrons of that atom based on my 3 rules that we mentioned before. Okay, so let's look at an example of oxygen, right? So when I wrote out my electron configuration, I had 1s2, 2s2, 2p4, right? And I make sure, right, oxygen has a total of 8 protons, so I have 8 electrons, right? 4, 5, 6, 7, 8, right? So my numbers here equal the amount of electrons that I have in my atom. So my first step was to write out my full electron configuration, so I've done that. My second step is I need to draw out my skeleton, right? And I'm going to do it like this, right? So I said every time I see an S, I draw out one square, and I'm going to label it 1s. Every time, right, I see another S, it's 1 square, label that 2s. When I see a P, it's 3 squares, right? Label it 2p. So you'll do that so on and so forth for every single orbital diagram, okay? Then I fill it in with my electrons, right? So my 1s, right, we know I'm starting with 1s, and I need to fill 1s before I move to 2s, right? And I have 2 electrons in 1s, so I'm going to do opposite arrows, right, based on, do you guys remember the rule? The Pauli exclusion principle, right? So opposite arrows, right? Once that is filled, I'm going to move to 2s, and I know I have 2 in here, so I'm going to fill one up here, down here, okay? Then I can move on to 2p, and I have 4 in 2p, okay? So I'm going to fill one up here, then move here, then move here, so all 3 orbitals are filled, and then my 4th will go here in its opposite rotation, okay? So that is how I will draw an orbital diagram, okay? For the opposite, right, I can kind of do this in 2 ways. One, I can count the number of electrons present and compare it to the periodic table, right? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So I have 10 electrons. If I am a neutral atom, I'll find element 10 because I know that protons and electrons are equal to each other in a neutral atom. And my number of protons tell me my atomic number, right? So I would find element 10, which is neon. So this would be the orbital diagram for neon, all right? Or what I could do is I can find my outermost orbital that I filled, right? 2p. I have 6 total. So if I find my 2p section, I find element number 6 of 2p, and it's also going to be neon, all right? Counting up the electrons is probably the easiest way to do that, though. All right. So what I want you to do right now is I want you to pause this video, and I want you to do the 2 problems in each section in your notes. I will come around and check it. If you need it, just raise your hand. All right. So pause and complete. All right. Last thing we're going to talk about is relating this all together for what we have learned for the majority of the second section of this unit, right? And we've been talking a lot about valence electrons, or the electrons in the outermost energy level. All right, so when I am looking at an electron configuration, right, I know that my big numbers, the 1, the 2's here, the 3's here, the 4 is here, tell me the energy level that I occupy, okay? And so that's going to be my outermost energy level will be the largest number. And almost all of the time, okay, and when I say almost, I mean literally almost all of the time, my whatever total electrons exist in my S and my P outermost energy level are going to be my valence shells, right? So if I have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p3, right? We're talking about arsenic, right? I have my Bohr diagram here, and it literally color codes where my S, P, and D's are, okay? Right? So, if I look at arsenic, right, 1s2 has 2. Then I move here. I have 2p6, or 2s2, sorry, then 2p6 to give me my total of 8. Then I move out here. I have 3s2, right, my 3p's, 6's, and then I have my 3d10s added as well. Then I move out, and that's when I hit my 4s2 and my 3p, or my 4p3, right? So when I'm looking here, I notice that my largest digit for my big numbers is 4. So I know my last shell is 4. And I said that valence electrons are my S and my P electrons, right? So if I have 2 electrons in my S subshell, I have 3 electrons in my P subshell. I'm going to have a total valence electron of 5, right? And I'm able to see that in my Bohr diagram here, right? 1, 2, 3, 4, 5, right? And to round it all out, right, I can now write my Lewis dot diagram, right? So keep in mind, right, that your valence electrons, look at your big number, look if it's an S and a P, and then add those electrons together to get your valence electrons. All right, so what I'm going to have you guys do right now, you guys have a worksheet to complete that you should have picked up because it's a shortened class today with early dismissal. You guys lucked out. I had another plan for you, but we'll do that maybe another day. So what I want you guys to do is you guys can exit out of the video, but keep in mind that when you're doing independent practice, I want you to write your summary, okay? I want you to complete your worksheet. I want you to check solutions, okay? And then if you're feeling really good about stuff, okay, and you're like, Miss Round, I got this, you can do your Mastery Connect, okay? I'll put the code on the board. But those are your 4 tasks before the bell rings, all right? So you guys are good to go.